Hello everyone. Today we are thrilled to share our project titled Human AI Interaction Feedback Based Intelligent Response Systems. My name is Xinxu and my teammate is Yiwei Wu. Next, let's start by talking about the current challenges with AI systems. Most of them are static, meaning they respond in the same way to everyone, regardless of the user's history or emotional state. This often makes interactions feel impersonal and frustrating because the AI doesn't understand or adapt to the user's changing needs or feelings. To tackle this, we aim to create an AI system capable of improving itself by learning from user feedback. We focused on answering three main questions. Can the AI personalize responses based on the user's sentiment? Does using feedback improve the relevance of AI responses? And finally, can adapting over time increase user trust? Our approach involved building a dynamic AI system with three main parts: a conversational interface that allows easy interaction, a feedback mechanism collecting explicit feedback like user ratings and implicit feedback such as user engagement, and a leading or learning module that uses this data to continually refine its responses. The technologies we integrated into our system include GPT 3.5 for generating realistic replies, NLTK, VADR, and an SVM model for accurate sentiment analysis, TF-IDF for keyboard vectorization, streamlined for a user-friendly front-end interface, and Proton to tie everything together smoothly. Our prototype allows users to input messages through Streamlit. It immediately classifies the sentiment of the input, generates contextually appropriate responses via GPT 3.5, and also adapts product suggestions based on user interactions and mood. Here you can see the actual screenshot of our system in action. Users interact naturally with the interface, receiving immediate sentiment-aware responses and adaptive suggestions tailored to their preferences and feedback. To test our system, we used a mixed method approach, combining both quantitative and qualitative methods. We had 50 participants divided evenly between an experimental group that interacted with the adaptive AI and a control group using a static version. We collected explicit ratings, behavioral data, and conducted interviews to deeply understand as users' experiences. The results clearly showed the advantage of our adaptive system. Response relevance improved by 31% in the adaptive system compared to only 7% in the static system. User satisfaction was also higher with a rating of 4.2 out of 5 compared to 3.4. Our adaptive system significantly outperformed in error recovery with 76% versus just 23% and improved contextual response accuracy by 42% for exceeding the 5% in the control group. Participants provided valuable insights. 83% noticed the system adapting over time, As users realized that their feedback genuinely improved the AI, their willingness to provide feedback increased significantly. Trust in the AI system also grew noticeably through ongoing interaction. However, some participants suggested that more transparency about how feedback is utilized would further enhance trust. While our study yielded promising results, it had some limitations. The 8-week duration restricts understanding long-term impacts, and our participants sample, although diverse, might not fully represent all user demographics. Users also expressed a need for clearer explanations about the AI learning processes. Ethically, we must continue addressing privacy, user data control, and potential bias concerns. To summarize, our findings strongly support the idea that feedback-driven AI significantly enhance interaction quality, user trust, and satisfaction. Adaptive responses that personalize interactions greatly improve user experience. Moving forward, we plan to conduct longer trials, enhance transparency around the AI learning processes, and explore the system's capability to learn from multiple users simultaneously. Thank you so much for your attention. We are looking forward to your questions, thoughts, or suggestions on our research.
Hi everyone, I'm Sinsu. Now I'm going to demonstrate our working prototype, a sentiment-aware chatbot system built with GPT 3.5 and Streamlit. This system allows users to type in any feedback or message, and it will perform three core actions. One, analyze the emotional tone of the message using sentiment analysis. Two, generate a natural language response using GPT 3.5. Three, provide a product recommendation based on the detected emotion. Now I'll give you an example, a positive example. Let's begin with a positive. I will type uh, um, exactly submit. The system analyzes the sentiment and recognizes it as positive. Then GPT 3.5 generates a friendly, cheerful reply, and the recommendation suggests our premium or newest products. This kind of feedback flow is ideal for an e-commerce applications encourage username. Now let's try our lective input. As expected, the sentiment is detected as negative. The chatbot responds with empathy, perhaps offering an apology or following up advice. The recommendation system how shows top-rated um, with better reviews, helping rebuild customer trust. Lastly, let's test a lateral statement. And this time the sentiment is classified as lateral. The response is balanced, and the product suggestion highlights popular items among users. Okay. This demo shows how we successfully uh, integrated sentiment analysis, AI-driven response generation, and tailored product recommendations into a single interface. By using GPT-3.5 and Streamlit, our prototype is lightweight, interactive, and easily extendable. Such a system could benefit customer service, online retail, and even mental health applications by making AI more emotionally intelligent. Thank you for watching this demo.